Hello guys, welcome to the next section, lists. In this section we'll get started with first steps where we'll learn about the basics. Then we'll learn about list head and tail and drop element. Moving on we'll learn to concatenate lists and learn about persistent data structures. We'll then move to tail call optimization. Then we'll look at list append and prepend. After that we'll get value at index and finally modify list value. Now we move on to the first video. First steps. This video introduces you to the basics of list. Lists permeate the functional world. Lisp is one of the earliest programming languages. The name Lisp means list processor. The imperative world also uses lists. In an algorithmic sense, lists are great for growing incrementally. List append is an O1 operation in the imperative world. Deleting and inserting nodes anywhere in the list is an O1 operation too. When we insert or delete a node, its predecessor and successor are the only nodes affected. A few pointers are juggled and the insertion or deletion is done. Consider this diagram. Here, when we insert node k, the algorithm is pretty simple. The algorithm would be set k.next equals c.next. Set c.next equals k. This works. Largely, as in the imperative world, mutating a node in place is okay. In the functional, immutable world, things are pretty different though. Let's define the list nodes. Firstly, let's briefly look at a sealed trait. A trait is just an interface. It may contain methods too. Let's look at the code for doing it. We'll first define the trait. A trait definition looks just like a class definition, except that it uses the keyword trait. Traits are used to define object types by specifying the signature of the supported methods. Scala also allows traits to be partially implemented, but traits may not have constructor parameters. Here we've defined trait A. Then we define class B and C. Here the classes are extended by A. We'll now define M of A method. Then we enter this line of code. The M of A method just handles objects of the type B. We'll now call the M of C method. When this is run, we get a match error. The sealed keyword helps in this case. We just need to change the definition of trait A as shown here. We've defined the sealed trait A. The sealed keyword ensures that the trait and its implementations are in the same source file. We now also need to redefine the B and C case classes. Just repeating the definition should be fine. Once we're done defining class B and C, we'll now redefine the M method as shown here. When this is done, the compiler generates this warning. Here, the sealed helps the compiler to perform the missing case clause analysis. You can visit this link for more information. We'll now implement the list, which is not from Scala's standard library. It's our own implementation and is defined as a sealed trait. This is the code. Here we first define the sealed trait. Then we define object nil using this code. And finally, define class : . This diagram shows a pictorial representation of the node hierarchy. Let's now closely look at our list definition. Here, this plus A makes the list type polymorphic. That is, it presents the list type as list int, list string, and so on. The plus sign in list plus A makes the type A covariant. If car is a subtype of vehicle, then list car is a subtype of list vehicle. Here in this code, nil is a case object, the only instance of the nil class. As this list is covariant, we'll now use this code. Finally, we have a case class with a somewhat strange name. The name is : . This allows us to define the list. We'll now define the list. This is the code for defining the list. Here's a diagram that shows how our list is composed. Constructing a list this way is awkward though. We'll now see how to construct a list easily. This is the code for doing it. The apply method allows us to construct lists easily. We define the apply method in the list's companion object. This method takes a varargs argument. Indicated by A*. It allows us to create a list with a simple syntax. If there are no arguments, then we get a nil list. This, as is empty line, is used for this purpose. In else statement line, the list has a head element and a list of 0 or more elements. As you can see, we set the head to the first argument. This is Scala's splat operator and is used to recursively define the tail. When the code gets executed, we get this output. This output allows us to define lists. We'll now define the list. And this is the output. Visit the site joelabrahamson.com for more information. Visit alvinalexander.com for more information on Scala's varargs and splat operators. This brings us to the end of this video. Here we defined and constructed lists.